Okay, hello. So welcome back to our statistics class. So we have finished our lecture on Unit 1, Part 1 and Part 2. Now we will proceed to Unit 2 of statistics. Okay, so Unit 2 is all about frequency distribution table. Okay, before we proceed to frequency distribution table, we have to first discuss this concept called rank. Okay, so this is similar to what we were doing in the ordinal variable. Remember the ordinal variable? Ordinal variable has quality. However, it can also have an order, or you can rank them. Okay, so rank tells us something about the degree of the variable. Okay, so these degrees can be arranged in ascending or descending orders. Okay, so for example, grades of 5 students. Okay, so here you have your student A until student E. Okay, and then they have their own respective ranks. Okay, so you can see here, right? So they have their own respective ranks. Okay, let's have a slideshow so to show you. Okay, so they have their own respective ranks. Okay, so student A has 80, and then student E has 95. Okay, so when we rank them, okay, so you rank them according to descending order. Okay, so when we say descending order, you rank them from highest to the lowest one. Okay, so among these five grades, among these 5 students, student E has the highest grade, so 95. So you put there rank 1, okay? And then so on until student A has the lowest, 80, you put them rank 5. Okay, what happens when there are ties? What happens to the rank when there are ties? They are counted as one, okay? So between the two, or between the ties, if it's 3 or if it's 2, you just take the average of them. So in this case, student B and student C has the same rank. Okay, so the two of them will occupy rank 3 and rank 4. However, since they are tied, we need to make sure that their rank are the same. So they will share rank 3 and rank 4. So we will take the average of rank 3 and rank 4, which is rank 3.5, and put them rank 3.5 for both rank 3.5 for student B and rank 3.5 for student C. Okay, so that's how you do your ranks. Okay, so that's how you do your ranks. For example, another example, example number 3, you have 3 ties. Okay, and then you have another 2 ties. Okay, what will happen? Again, they will share the ranks. Rank 1 and 2 will be shared by student F and G. So what's the average of rank 1 and 2? It is 1.5. So they will share, they will have the same rank 1.5. And of course, student B, student C, and student D are all the same. They have the same grades, so they will all share the same ranks. They actually share rank 5, rank 6, and rank 4. Okay, so rank 4, 5, 6 was the average. It is rank 5, so they will all share rank 5. Okay, student A is rank 7. Okay, don't be mistaken, it is student A is rank 7. Student A is not rank 6. Okay, it's because student B, C, and D already shares rank 4, rank 5, and rank 6. Okay, so student A is left with rank 7. Okay, so I hope that's clear. Okay, okay. Now let's proceed to frequency distribution table. Okay, So when we say frequency distribution table here in unit 2, this this actually is your foundation, no, for the explanation of your statistical techniques. Okay, frequency distribution for nominal, ordinal, interval data is presented through this table. Okay, so after working on this unit, you should be able to arrange given set of data into an array. Okay, we will discuss what is an array. Set up frequency distribution table for nominal, ordinal, and interval data. Okay, construct cumulative frequency distribution table and interpret different types of frequency distribution table. Okay, so let's first go with array. What is this array? Okay, array is just an arrangement of data according to size or according to magnitude. It is simply obtained by arranging the values in either ascending or descending order. Okay, so that is an array. For example, the scores of 15 students in a 35 item test in statistics are arranged in ascending order as follows. Okay, so here let's have an activity. Okay, so what is an array? We have just discussed it. Prepare an array for the following data. So we have the scores here, or data here. Then you need to prepare for an array. Okay, how do you do that? First is you will list all the scores. Okay, these are the scores: 20, 20, 21, 24. You arrange them in ascending order. So these are the 15 students. Okay, so you arrange them in an ascending order. Okay, so this is an array already. These are the scores of students, 15 students, arranged in ascending order. Okay, so you can analyze from an array here, an ascending array, that you can deduce that there are no students that got the perfect score. Why? It's because 35, it is a 35 item exam. So the highest is only 32. So no student got zero, and no student got a perfect score. Okay, two students are actually tied to, with the lowest score of 20, no, and the one that top is 25. And what's the average scores of the students, or the middle value? It is the mode, or the most frequent one here is the 25. Okay, so that's how you interpret an array. Okay, so now what is frequency distribution table? So your data actually can be organized or tabulated into a distribution table. Okay, so distribution table is the arrangement of your gathered data by categories. Okay, and these categories have corresponding frequencies. Okay, so these frequencies indicate the number of data, or the number of observations falling into each category. Okay, so a class interval contains grouping. Okay, they are defined by limits called lower and upper limit. Okay, we will discuss it as we go through it. Okay, so I want you to memorize these terms. Okay, if you cannot memorize, at least know what it is. So when you solve, or when you create the table, you can already remember, oh, this is class frequency, oh, this is class interval, no, this is the upper limit, this is the lower limit. Okay, this is the class mark. Okay, so these are the definitions. Frequency distribution refers to the arrangement, or to the tabular arrangement of data by classes or categories. Okay, class frequency refers to the number of observations belonging to a class interval. Okay, class interval refers to your grouping or your category. Okay, it is defined by lower limit and upper limits. Okay, then your class boundaries refers to a precise expression of these class limits, okay, by at least 0.5 of the values. Okay, so they are called the true class limits. So uh, it is just really minus 0.5 on the lower limit, and then it's just plus 0.5 on the upper limit. That's your class boundaries. Okay, class limits, it is the end of the class and the lowest limits that can go into each class. Okay, class mark, or it is called midpoint, it is the average of the lower and upper limit of each class interval. Okay, and of course the most important one is class size, it is the width of each class interval. Okay, so this class interval and class size, you need to remember this because this actually will define your table. Okay, how do you determine the size of a class interval? Number one, getting the difference between the upper and lower class boundaries if the lower and upper class boundaries is given. Number two, by getting the difference between two consecutive upper limits if the two upper limits is given, or by getting the difference between any two consecutive lower limits, again if the lower limits are given to you. Okay, let's have an example for you to visualize. This is an example of a frequency distribution table for nominal data. Okay, so here to table 2.1, we have your high school graduates for school year 1997 to 1998. You can see here sa table, we have your categories, your male and female. This is your class interval, male and female. Okay, so your sex can only be categorized into male and female. Okay, so your male and female is your class interval. Now frequency, this is your class frequency. Class frequency meaning the number of observations within that category or within that male. How many males are there in your observation? How many males are there in the high school graduates for school year 1997-1998? 28. So you put that 28 into the frequency column. Okay, so how many female high school graduates for school year 1997-1998? It is 32. So the 32 there, you should put it on the frequency column. Okay, so male 28, female 32, so your total frequency is 60. Okay, so this is a frequency distribution table for nominal data. Okay, it is very easy. Why? It's because it is a nominal data, you cannot exactly measure the categories, right? So sex can only be male, female, they cannot be measured by numerical measurements. Okay, so it's only male and female, and the only thing to do is to find out the frequency, or how many males are there or how many females are there. Okay, now let's have an example of frequency distribution for ordinal data. Okay, again, ordinal data, as I have said, it has quality like nominal data, but it has order, or you can rank them, one we discussed a while ago. So example of ordinal data is your performance evaluation of ABC employees. Okay, the performance evaluation is an ordinal data. Why? It's because the performance evaluation is categorized into unsatisfactory as the lowest, satisfactory, very satisfactory, and then outstanding as the highest. Okay, so similar to the frequency distribution of nominal data, the frequency distribution of ordinal data is also easy to create. So the only thing you need to create is your categories or your class interval, and then your frequency. Okay, what are your categories? Unsatisfactory, satisfactory, very satisfactory, and outstanding. Okay, what are the frequencies? So you just need to know how many employees are performing unsatisfactorily. So 2. So you put that in the frequency column 2. Okay, how many are satisfactory? 7. You put there 7. How many are performing very satisfactory? 23. So you put that as 23. And how many are outstanding employees? You put that 8 there in the frequency column as 8. Okay, so the total is 40. Okay, so this is how you do your frequency distribution table for ordinal data. So nominal data, similar one. You just need to put the categories, just put the phrases there. For ordinal data, same is true. You put the categories there, you just arrange them, okay, and then you just put the corresponding frequency or the number of observation within each categories or within each class interval. Okay, let's go on with frequency distribution for interval data. Now for interval data, this is where it gets tricky. Okay, because your class interval is now composed of numbers. Okay, it's not anymore words, it's not anymore phrases. So it's actually composed of numbers. Okay, so interval data are actually organized into group frequency distribution in order to separate the scores into fewer categories. So instead of having a random data and arranged data, so you need to organize it, okay, and put it into a distribution table like this. Okay, so here your table 2.3 shows a frequency distribution for your monthly salaries of 75 employees. Okay, so the monthly salaries, as you can see, it is grouped into your first category or your first class interval is your class interval 5,100 to 5,599 pesos. Okay, how many employees there? How many employees? So 10. So that is your frequency 10. You put your frequency 10 there according to how many observations are there in that class interval. How many employees have salaries of 5,100 to 5,599? 10. So you put it 10 there. Okay, and so on. No, you need to see that the class interval is increasing. Okay, so 5,600 to 6,099. So if you actually compute it, what is your class width? How do you determine the class width? First, you can subtract the upper and lower limit, right? So you can subtract your 5. What is the upper and lower limit here? So in a class interval, there are 2, right? So your upper limit is the larger number. So here in the class interval of 5,100 to 5,599, which of these two is the upper limit? It is the larger number, or your 5,599. Okay, that is your upper limit. And the lower limit is of course the lower number, 5,100. Okay, so how do you determine your class size? You can subtract the upper and lower limit in a class interval. So you can subtract 5,599 minus 5,100, and that will actually give you 500. So that is your class interval. Okay, so or second method, you can just subtract 5,599 minus 6,099, or you can subtract 2 upper limits. That will also give you 500. Okay, and another one, you can also subtract 2 lower limits, or your 5,600 minus 5,100. That will also give you 500. Okay, so the class size here in this frequency distribution is 500. Okay, okay, again, this is how I got it, the class size. Okay, so by getting the difference of between the upper and lower limit of a class interval. Okay, so that's what we did kanina. Or by getting the difference between any two consecutive upper limits. Again, we subtracted 6,099 minus 5,599, and we still got 500. Okay, or by getting the difference between any two consecutive lower limits, we subtracted 5,600 minus 5,100, we still got 500. So the class size is 500 for table 2.3. Okay, okay, so the question is, how will you construct a frequency distribution table? What's the steps? Because a while ago we were actually already given the table itself. What if you wanted to do, or you wanted to create your own? You have your experiment, you have your data, you wanted to create your own. Okay, what should you do? Okay, these are the steps. Okay, first, if you have your data, your raw scores, this is how you will actually create a group frequency distribution table. Okay, so first you need to find the highest and the lowest score among your data. Okay, so do not be mistaken, you need to find the highest and the lowest score. Okay, those two are important. Okay, so step number 2, you determine the range. How do you determine the range? You subtract the highest, okay, and you subtract the lowest. You subtract the lowest from the highest. Okay, so your age minus L, that will give you your R, or your range. Okay, and then number 3, you need to choose a convenient class interval size, or your small letter I. Okay, that can be the width. Okay, so that there will be not fewer than 10 or more than 20 class intervals. Okay, so this is the ideal one that you need to choose. However, if your professor said, or your exam told you the class interval size to be 20, then you should follow the 20. Okay, so to do this, you need to divide the range by your chosen interval size, or your small letter I. So R divided by I. Okay, and then after dividing it, you round up the quotients to the nearest odd whole number. Okay, why odd number as class size? Okay, it is preferred because the midpoint, if if it is an odd number class interval, the midpoint will be a whole number. Okay, so if you divide it, the midpoint will be a whole number instead of being an even class size, or class interval size. Okay, which will result into a decimal point. Okay, so it is preferred to have a whole number as your class, or as your midpoint. So it is preferred to use an odd class interval size. Okay, and then after that, you need to establish the class intervals. How will you establish it? You need to begin with the bottom interval with the lowest score. Okay, you have your lowest score, right? And then make sure that it is a multiple of your small letter I, or your class interval size. If the lowest score is not a multiple of I, you need to begin with the lowest multiple of I that is lower than the lowest score. Okay, or your lowest data. Okay, so that your lowest data will be included in the lowest class interval. Okay? So remember that you should start every class interval with a multiple of your class interval size. Okay? There should be enough class interval to include your lowest and your highest score. Okay? So all the class interval that you need to write should include all the possible observations, all the observations you have in your data. Okay? Then after that, step number 5, starting with the upper left class interval, draw a line above it and mark class interval, and then place your tally mark beside it. So after creating your class intervals, you will now determine the frequencies for each interval. So you need to count, look at your raw data, and you need to count how many observations or how many data are included in this class interval, and then you put, if it's 3, then you put 3 there in your frequency. Okay, it's 5. Okay, and make sure that the total number of your frequency is equal to the total number of your observations in your raw data. They should be equal. They should not be less, they should not be over, they should be equal. Okay? Okay, it's hard to imagine if I'm just explaining with words. So let's try this example. Okay? So we have here your chemistry test scores of 40 students. Okay? So we have 40 students here. So these are the scores of the following. Okay? So it is here in a 10 by 4 table. Okay? So we are tasked to create a group frequency distribution of this interval data. Okay? Interval variable. Okay? So find the highest and the lowest score. So among these 40 students' scores, who got the highest? It is 52. And who has the lowest score? It is 10. Okay, so we have the accomplished step number 1. Okay, step number 2, we will determine the range. Okay, your range is your highest minus your lowest score. Okay, so age minus L. So what is your age? 52. And then your lowest is your 10. So 52 minus 10. Your range should be equal to 42. Okay? So that's, we're done with step number 2. Okay? Step number 3. Here, you need to choose a convenient class interval or your small letter I. Okay? It will depend on you. It's either 10 or 20, or it will actually depend on the problem itself. If the problem says you need to create a 7 class you need to create 7 class intervals, okay, you should divide it by 7. Your I is 7. Okay, so here there is no given class interval numbers, so you can just decide it. It's either 10 or it's either 20. So you can divide the range 42 by 10, 4.2, or you can divide it by 20, 2.1. Okay? Remember that you want an odd class interval. So what's the nearest odd number between 4.2 and 2.1? It is number 3. So your class interval size should be 3 because it's the nearest odd number there. Okay, now step number 4, we need to establish the class intervals. We need to begin with the lowest score if it is a multiple of I or your multiple of 3. What's the lowest score? If you remember, it's 10, right? Is it a multiple of 3? No. So where should we begin? It should be the lowest multiple of 3 that is lower than the lowest score. So what's the lowest multiple of 3 that is lower than 10? It is number 9. Okay, so number 9 should be the start of your class interval. Okay, so instead of 10, it should be number 9. Okay. Okay, so the lower limit is number 9, and then from there, lower limit number 9, you need to proceed with each class interval. So remember that each class interval has lower limit and upper limit. So if you, the first class interval, the lower limit is 9, what should be your upper limit? Remember that the difference of upper limit and lower limit is your class size, and your class size is 3. Okay, so class size is 3. So what if your class size is 3 and your lower limit is 9? What should be your upper limit? So you need to count from 9 3 units. Okay, 9, 10, and 11. So that's 3. So your upper limit should be 11. Okay, so that's your first class interval. As you can see in the bottom, it is 9 to 11. Okay, and then you need to count until you created the last class interval. Okay, what should be the last class interval? It should include the highest score. What is the highest score? It is 52. Okay, so highest score is 52. It should be included in the highest class interval. So you should stop actually when 52 is included in the class interval. So what's the last class interval here? It is 51 to 53. Does the class interval of 51 to 53 include 52? Yes. So we should stop there. 51 to 53. Okay? So you create the class intervals from 9 to 11 until you stop at 51 to 53. Okay? So the lowest class interval should include the lowest score. What is the lowest score? 10. Okay? So 10 is included in 9 to 11. And then your highest score should be included in the highest class interval, 51 to 53. Your highest score is 52. So 52 is included in 51 to 53. Okay? So that is your class interval. Are we finished? No, not yet. We need to have the frequency column, okay, or your tally. You need to count. You need to count observations, okay? How many scores in those chemistry scores of the students fall or are within 9 to 11? Ilan? So 2. So you put 2. How many are within 12 to 14? 1, you put 1. How many are within 15 to 17? You put 5. And then so on. How many got scores of 51 to 53? It's just 1. So you put 1 there. Make sure that when you total all the sum or the sum of the frequencies, it should be equal to 40. Okay, so if you add 1 plus 2 plus 1 plus 1 plus 4 plus 8 plus 5 plus 4 plus 2 plus 4 plus 5 plus 1 and plus 2, that should be equal to 40. Okay, so it should not be equal to 41, should not be equal to 39, it should be equal to 40 because there are 40 students or 40 scores in total. Okay, so this is actually your group frequency distribution table of interval data or interval variable. Okay, so this is how you create your frequency distribution table. Okay, so again, these are the following terms that you need to remember. Okay, so I want you to memorize these terms. You need to memorize them by heart. It's because you will actually create these table frequency distribution based on your understanding of these definitions. Okay, okay, cumulative frequency. How do we create cumulative frequency? We can create cumulative frequency. Oh, let me you can create cumulative frequency by tallying again. Okay, so you have what you call your less than cumulative frequency and then greater than cumulative frequency. Okay, so here you can see this is what we did a while ago. This is the group frequency distribution of chemistry scores. Okay, so for cumulative frequency, you just create the normal group frequency distribution table, and then you add another column or your less than cumulative frequency and your greater than cumulative frequency. When we say less than cumulative frequency, you start at the bottom, you start at the lowest, you have your 9 to 11, so you write 2 here, okay? And then from the word cumulative, it will accumulate, okay? It will accumulate. So 2 plus 1, that is 3, okay? So 3 plus 5, that is 8, okay? And so on, it will accumulate, okay? So that is your cumulative frequency distribution table, less than cumulative. What is greater than cumulative? You start at the highest, or 51 to 53. So you write 1, and then the next one is 2 plus 1 is 3, and then 0, so it will be 3 again. So plus 1, that should be 4, plus 1, that should be 5, and so on. You just add them. That is your greater than cumulative frequency table. Okay? So that is how you create your cumulative frequency tables. Okay, so we have finished our unit number 2. So I will be discussing again unit number 3 the next meeting. Okay, I'll see you all again on unit number 3.